Okay, guys, welcome back to yet another episode of DSA Python series, and today we will continue our lecture or say discussion on linked list. Okay, so remove linked list. This is lead code 203. I've given the head of linked list as an integer val. Okay, remove all the nodes of the linked list that has node val equals val. Okay, and return the node. It means that here is an example. You have this head. Okay, head is equal to this, and your value is equal to 6. So whatever is the value 6 given, okay, you just need to remove all these 6, okay, from the linked list, okay, from the set, and your output should be like this. Okay, so your output should be in the form of linked list only. Okay, so head is given integer val, remove all nodes, right? So how we can do that? Okay. So first of all, we have we will pass some value head, okay, and the value, and I will say head dot val, okay, is equal to my value. Okay, then I will just return head dot next. Okay, current dot next. So I will just say while current dot next. So this will go. Okay, and in if statement, I will just say the value, if that value is equal to that val, okay, then I will just do something. Okay, so if current dot next dot val is equal to this val, right, right, I will have this with if statement. Then what I'll do, I'll just do current dot next is equal to next dot next, okay, because it will just, we will just skip it. So whatever is my current dot next ka value, okay, so current dot next, yeah, yes, yes. So this will be the logic. If current dot next val is equal to value. It means that let's say I am here, my current is here, and my current dot next val is equal to 6. Then what I'll do, I'll just do current dot next co should be equal to this one wala, right? So in its place 3 will come. Okay, so after 2 3 will come. Hmm. So simply we have to just make current dot next as current dot next, right? This object we have to bring here. Okay, so whatever is its value, it will assume this, right? So 6 will be assume the value of 3. So when 6 assumes the value of 3, it means that the 6 is removed automatically, right? So this should be the logic. Okay, and every time we have to change our current. So uh, out of this if statement, current is equal to current dot next. Now I have to define the current also, right? So what I'll do is initially I have to put my current as uh, head, right? So I will just do current is equal to head, right? So head we have given, so it will not throw any error, right? And in the end, what I have to return, I have to return my head, right? In the end I have to return my head. Right is none. Return head. I'll just return. Head is going to return 1. I would first need to remove my matching nodes from the beginning. I'll just can I just remove matching nodes from the beginning. So L is equal to 6. So while head and head dot val equals val, it means that, let's say, here my value is 1 and my head is also 1. Okay, for example. So what I'm doing here is, uh, I'm doing head is equal to head dot next. So it will go to 2. Okay. So head is equal to head dot next. So this 2 is no longer a head. So head becomes head dot next. So now the value of head becomes 2, right? So then it will check head dot val is equal to val. So it will be head dot val is 2 here, and val is 1. We have considered it as 1. Okay. So is it true? No, it is not true. It is false. Therefore, uh, while head is true, but head dot val is false. So uh, true and false will be false, right? So then loop will stop. What if there are multiple nodes to remove? Let's say we have 6 value as 6. So how the iteration will do? Head dot val is equal to val. Uh, so 6 is equal to 6. That is true. So it will do again head is equal to head dot next, right? Then the head will go to the next 6. Okay. If there is a repeated 6 value, again 6 is equal to 6. So again head dot val head is equal to head dot next. So we are actually changing the value of head every time in every iteration. Okay. So as far as the value is coming true, it will keep iterating. Hmm. So we are every time doing head is equal to head dot next. So uh, what if our this thing head is 6 comma 6 6 comma 6. So and our value is also 6. Let's say our val is equal to also 6. So what it will check, it will keep doing head is equal to head dot next every time. Okay. And it will compare with the value, while head and head dot val is equal to val. So it will check both the condition, the value of head also. It will keep doing head is equal to head dot next. So after the last 6, the value of head will be none because head dot next, like after 6, after the last 6, there is nothing, no element. So the value of head becomes none. So after that, we are checking if head is none, right? So if head is none, we will simply return none. It means that the element which we have deleted, after deleting the element, we are getting nothing out of the linked list, right? So that is what the logic here is. Okay. Um, and let's say after this it is 5, 7, 9. Okay. So after second iteration, the head dot next will be at 5, right? So the value of head becomes 5. Okay. And then it goes to this, right? It goes here, head is none. Then it will go to here. So current is equal to head. So right now the value of head is 5. So my current will be at 5, right? Now we will do current dot next. Okay, so if current dot next dot val is equal to val. Okay, let's say if current dot next, this one, is equal to val, it will do simply current dot next is equal to current dot next dot next. So it will, the one variable, one element leaving, the next element will be the position of this element, right? So in place of let's say here again we have 6, so we are at 5. Okay, so our head is 5, right? Now while we will do current dot next. Okay, so let me just check why, what does this mean? Means, okay, what does it mean? So it means that while current dot next means keep looping as long as there is a next node, right? So it means that while current dot next means that this will keep looping as long as there is next node. So suppose your linked list is this. Okay, so current dot next will be 20, right? So when current reaches 30, current dot next will be none, right? So while current dot next, compare this to while current, right? While current dot next, remove code. Okay, so this is basically the thing, right? Okay, no screen sharing. And let me remove linked list. Is it okay? Like, can you see the screen? College वाले ACM IC college are providing ACM IC. Yes, of course you should take part. Of course you should take part in it. Is my screen visible now? Mr. Arpit, colleges are promoting ACM ICPC. You should take part in ICPC, man. It's a good competition. So ICPC is a very nice platform where it is the most prestigious competitive programming competitions for you people, all the university students. Okay, so ICPC is like you will be given one computer which will be shared by the team, and it is usually of around 5 hours, right? And typically three students form a team, right? And so you may have competitions regionally, then you do have competitions worldwide also, right? So for ICPC you need to learn all core DSA programs, problems, all critical advanced algorithm, right? Like DP, graphs, right? Greedy algorithm, dynamic programming, bit geometry, combinatorics, right? You should also practice competitive programming skills. So, you can do that in code forces, or there is weekly contest of lead code, so that you can try out. Okay, so that will increase your competitive programming skills, right? And it will help you to get the faster implementation of the code, right? You can easily do the complex analysis, right? Debugging skills, and you can easily recognize the patterns, right? So your analytic and mathematical thinking will develop. Okay, so that's how you go for it. Very challenging. So what we are basically doing here is, so I need to remove the matching nodes from the beginning, right? If the node is matching, then I have to remove it. Okay, let's say uh, here the node is 1. Okay, so let's say my node is 1, and my value is also 1 here. For the time being, let's consider the value as 1. Okay, so what this will screen out is this code. What it will do is, um, the head. Okay, so this is the head, and the head dot val. Okay, so first of all my head is here. Okay, and my head dot val is 1, and my head is also 1, right? So when both are true, right, and equal to val, then it will do head is equal to head dot next, so it will jump to this one, right? Okay, now what about 2? My val is 1, right? So it will give false result, right? So when it gives false, it will come out of the loop, and it will check here. If head is none, return none. Is head none? Because right now my head is 2, so head is not none, so it will go here. Now it will take the value current, or you can take temp. Okay, whatever it feels like. You take this value, current is equal to head or temp is equal to head. So the value of temp will be 2. Now you play on this temp only. Your head will be 2. Okay, it means that you have already removed 1, right? And in the end, you, because you are returning head, so all the values which are, current dot next equals value, all these values will be deleted, will be removed from this, because you have this one command which will do, if your current dot next ka value is equal to value, it means that you have to bring the next to next wala node to the next node, right? So the next node will be deleted. That is how you are performing this. So how you can count the nodes of linked list? Let's execute this now. Let's submit this. Okay, there is some runtime error is coming. Okay, this you deleted. This was just I gave for example. So now you can see here. Let's see the analysis. What analysis it is giving. So iterate through linked list to remove nodes with specific adjusting pointers. So we are basically did this. Showing solid mastery of linked list. Okay. How would you handle this if the list was doubly linked? Would a sentinel node? Okay, so this we will do when the link is a doubly linked list, right? So this is complexity is O of n because we are iterating through this loop. Okay. So the time complexity becomes time complexity is equal to big O of n. What is the space complexity? It will be space complexity will be O of 1 because we are not taking any extra space, right? Are we taking? We are just considering this current, which will have only one element saved, right? And every time we are changing the value of current. Okay. Okay. So so these are all other challenges which are given. Delete the middle node of a linked list. This we can do. But before jumping on to such questions, we will first try doing basics. Okay. So if our basics is strong, then we can jump on to these questions. Okay. Because these are maybe some middle level question. Yeah, medium question. Okay. So this is the medium question. Okay. So that we can do later on. Got some badge. Okay. So okay, so I've got this badge, Dear Mohan Pardi, congratulations, 50 days badge of 2026. Solving problems 50 days in. Let's generate the image. Let me just save this badge. Save images. Okay, so now we can go for doing another question. Okay, let us try counting the nodes of the linked list. Okay, so we have this function def get count self comma head. Okay, so it means that the head is given. Okay, single linked list, find the length of linked list where length is defined as the number of nodes in a given linked list. So what we will do, we will assume a temp, or you can say the count. Okay, so let's say our count is equal to 0, right? While head is none, right? While head, what was that shortcut? Okay, while let's say temp is equal to head, right? So while temp dot next, right? Dot next. Okay, so it will loop as long as we have the temp dot next is not none, or you can say is not none. This also you can write. So we will just do temp is equal to, sorry, count is plus equals 1, right? And temp is equal to temp dot next. In the end return temp, I think, if I'm not wrong. Next. just doing temp is equal to temp dot next, and if I don't write this, it will also keep looping. Okay, I have to return count, not the temp. Okay, so my output is coming for y because okay, because I have already so I have to do count plus one, right? Because I have already considered this head as my temp. Okay, and this is counting from the next element after the temp. Okay, so temp is has been missed. Okay, so I will just do return count plus one, right? So it will be okay. Okay, yeah. And if I say is not none, then also it should work. Okay, so this is how this question is getting solved. Right. Now, search search an element in the linked list. How you can search an element in the linked list? So all this question is done. Getting up to sorted array. Guys, these are all the rankings. You can see here rank is very high. It depends on how many questions you solve on the platform, right? Okay, so how we can search the element in the linked list? Okay, so we have given a linked list with the head node is given, right? Only head node and a key. The task is to check if the key is present in the linked list or not. So example is input key is equal to 3. Okay. So I just need to check whether my key lies in the linked list or not. If it lies, then I just have to return true, and if it doesn't, then false. Okay. So when 3 is present here, our output should come true, right? So how do we do that? Um, let's start traversing the loop. Okay. So we have simply the traversal formula while temp dot next, right? So this is the traversal, and it will traverse. Now it should start from head. So let us do temp is equal to head, right? Initially my temp is the head. Okay. So I have kept my temp here. Okay. And it will start doing temp dot next temp dot. So when my temp is equal to head, so I just give one condition: if temp is equal to key, I'll just return true, right? Because this temp is not getting covered here in while loop, right? After this break, okay, so it will jump to this loop, right? And if temp is equal to key, right? Temp dot next. I'll just return true, and I will say temp is equal to temp dot next. Else false. Just remove it. Graph. So instead of that, we can use data, because here data is used. Okay, so this is working now. So in class node, we have created a class node where we have assumed this uh, data as the value which will be associated with the node, right? Self dot data is equal to data, self dot next is equal to name. Right? So this is the empty node which we have created, right? And after that, we will search the key where it takes the argument head and key, right? So head we have been given, right? So, and while temp, can we use temp dot next? Okay, so you can see here all the test cases are passed, right? So temp will visit every node including the last node where temp wants to move through the temp. Settle node. Okay. So this is submitted. Okay. Okay, guys. So this was all about linked list and its operations, right? Tomorrow we will do the how to design a linked list, right? And how to insert a node in the linked list. So these two we will do tomorrow. Okay. So till then, bye and take care. Good night.